Welcome to part 12. Let's have a look at some real-life scripting examples. If you don't have BZR yet on your machine, you can install it using yum install BZR, or if you're using, for instance, Ubuntu, simply go sudo apt-get install BZR. Once it is installed, BZR branch, launchpad, indicated by the LP, colon, Percona-QA. In my case, I have to enter passphrase for my SSH key. And there we go, it's downloading Percona QA. I'll pause the video for a few seconds while this is going. Okay, there we are. So it tells you how many revisions that it's branched. And as soon as you've downloaded it, it will be available in the Percona QA directory. You can have a look at the history of whatever commits have been made to it. My colleague Ramesh and myself, and times David as well. We push regular to this repository. So let's have a look at some of these files. And my colleague Ragvendra, regularly pushes to some of the PXC scripts as well. So let's have a look at startup. Startup is simply just a script that creates a number of handy utilities. Maybe I should just simply show its use. Okay, so here we have a standard MySQL distribution untarred tarball, and we run startup like this, and it basically just runs MySQL install DB and creates a bunch of scripts like start. That basically just starts the server. We also have init, and if we run init, it quickly wipes away whatever is there and just resets up the server cleanly. We can start the server, and after a few seconds we can enter the client, and we can stop the server, and just everything is standard and easy to run. For example, I have a shortcut on my keyboard. If I press Alt-P, just look what happens. It swaps into an early build of Percona server on 5.7. It will stop if it's running. It will wipe away whatever is there and bring up a client. So basically just pressing Alt-P will get me to a command line, which is very handy. You can see how you can automate pretty much everything that you do on a regular basis. So let me just stop Percona server here and just go back to the scripts. So we were looking at startup, which was doing all this before. So let's have a look at some of the things that are happening here. For example, here it assigns a random port number from between 10,000 and 20,000 to the variable port, which is then later on used, and a number between 100 and 700 to the MTRT variable, which is then later on used for MTR. What other interesting things we can see? Uname, we've looked into that before. So we're checking here if we're running on Ubuntu, and depending or not on that, we will install different bits and pieces. Here we are checking if the first variable to this script is empty, and remember how we use double quotes and we always encapsulate our variables, and you can see that exemplified here. We always put quotes around our variables to make sure that we don't get that error that we've seen before. Then depending on, and here in a previous part of the script, the binary, the MySQL binary is assigned to the variable bin, and we're checking with grep minus OE, and what this does is it's very handy. It just the O only selects what is grabbed. So to give an example, go 1, 2, 3, 4, 5, 6, 7. Grep minus O tray. See only what is actually found, or if we use a bit of regex here, any character, only what is found. Very handy way of writing things. Again, we check for some inequalities. We again make sure that the variables are surrounded by double quotes to make sure that we don't get errors. We say here if this file exists and is readable, but the opposite. So if not this file is reading, if the file is not there, then you can do this. So I'm just realizing that, for instance, in this case, an A check might be better because that at least negates the possibility of having a file there but not in a readable format and this script failing. So I think I'll just leave that change. Here we're checking for the non-presence of a directory and so on and so on. Here we're checking if the variable 1 is 0, and that's how we used it in the example. And if so, execute a number of things, and you can see how you can have multiple nested ifs, etc., etc. To make there minus p with a number of directories, most of these wouldn't be existing, so we say minus p, and that means if it's existing, do not complain. However, if it's not existing and you have to create a parent directory, please create the parent directory again with complaining and without complaining, and so on. Let's see what other interesting bits we can find here. So here we're sending a command without actually executing it. We're just simply sending the command that has to be executed if the init script is run into the init script, and then you saw how we ran the init script there, and then from that this particular command will be executed. So this is all regularly done where you echo a number of commands, possibly containing variables. Like here you can see how variables are being worked into whatever it is that needs to be executed into a script, and then that script later on can be executed. Here in fact we are doing that, so this is probably just the actual setup stage. Notice here how we're doing an if statement, and here's something that we haven't seen yet, minus a, which means and. So we are making sure that variable 2 is not man2, and we're making sure that this particular directory exists, minus d. So you see how you can combine very powerfully two of these various if clauses, if conditions. Okay, so change the privileges recursively. We've seen that 777, which means pretty much all writes to a particular directory. Tar, which we haven't really looked into, but just an example of how a tar statement gets built. Here we're using set, and we've seen set, and you can see some of the regex syntax. So starting off the line, any character, then this particular text, replace this by this particular text, and so on. In this case, we're piping through, and this is very interesting. Notice this trailing backslash here. If we had a space behind this, notice how the color changes. This would be interpreted as a literal slash. Always make sure that if you put a trailing slash at the end, which basically means interpret the next line as part of my ongoing command, make sure that there's no spaces, and you can do that by typing /, which means search, and then space. And you can see now how all spaces are highlighted. You can see there's no real space here, so that's all fine. So in this case, we're outputting a particular file, and we're grabbing for a little bit of text, and then our command continues. So we're using a pipe here, and our command is going to continue on the next line. And replace, we've looked into that. Here something similar. Here we're saying if it contains either of these 0 or more times, then replace by this. See if there's something else interesting. 0 to 9, we've seen this also, so this means 0 to 9 x amount of times, including 0 amount of times, and so on. Here again, a negated file check, so we have a file check, but it's the opposite. Okay. See if we can see anything else which might be interesting for us to have a look at. Here we are setting a directory variable, so this is just a variable, to a subshell, and at some point we should change this into the subshell syntax that we've seen with the dollar parentheses, but here are just backticks used. And so we're getting this particular file, we're grabbing a little bit of text from it, we're grabbing only a very specific, see the -o used there again, only a very specific part, and in that part we're changing something, and all this is just encapsulated and then inserted into this variable. Something similar goes on here. And you can see how by doing this we can again build quite powerful scripts. Here we see how the variable passed to this script, in this case it wouldn't be 0 but it would be a trial number, is used as part of the file name, and you can just write it at the end of it. So Bash is very flexible as to all the things it allows you to do. Here we see like a few commands being just joined together on one line, maybe just for ease of readability, and these just refer all more or less to the same thing, so why not write them on one line. Here the file gets created for the first time with the contents of J1, and then J2, J3 and J4 are being added onto it, which we can see by this second greater than here compared with the just single one at the front. In this case we're again checking for a particular item, and we're negating that by the exclamation mark. We've also seen how we can make files executable, and of course we have to make certain files executable just to make it easy for the user straight away to run it. Okay, let's have a look at another example. Okay. So in this script there's a fair bit of text output to the screen. So here we have a for loop for I in 1, 2, 3. We do a number of items. We're going to extract queries from the core, and this is done in another script, and we're sourcing this script. We haven't really seen sourcing of scripts either. Just for the moment, remember that if there's a single dot in front of a script, then it means that we're sourcing another script. So we're going to run a particular script and see how here the working directory of the script is being inserted just flat out straight into the file name. Some variables passed so that the subscript knows what to do. Again, we're making sure that we have quotes around our variables. We're checking for some output. And here we're assigning a variable to an output of a script, and we're counting the number of lines. So all of this is fairly straightforward. Here we have a little bit more complex syntax, so we're interleaving within the file itself. Remember how we saw that every 5 lines we're reading this particular file, the failing SQL, and we're inserting that into our input file. We're checking some variables to see if they're greater than or less than, equal, greater or equal, less than or equal, etc. We're just doing a whole bunch of replaced, and see how all of this is just a single line. You can see that by the terminating slashes at the end. So all of this is just one single line of a whole lot of sets where we have a whole number of replacements happening from one thing to another. And even here we are using a replace, which is previously defined somewhere here, multiplying 2, and you can see this long line here, which is basically just directly inserted here. So it's all very flexible. You can see how you can insert one thing straight into another. Here we're using a for loop with based on directory output, and another for loop based on yet another directory output, and you can see how we're hashing sort of it into the way that we want. For instance, grab anything that starts at the beginning, has just at least a bunch of numbers, and then ends, and so on. Here you can see a few nested if statements. Okay, let's have a look at another script, reducer, which we'll look into a lot more later on in this series, and see if we can find anything interesting. So here we have a random port assignment in the 40,000 range, and look at this. Here we're running a subshell and we're saying netstat -an, grab a particular port, the one that's been randomly chosen here, count it, how many you see, and do some cleanup there with tr, and you can see how it's deleting tabs, new lines, and spaces, probably just to make it more parsable. And then we check against that, and if there is a port collision, then we're going to just loop through that, and you can see the while do here. This is just a shorthand for while true, the while true that we saw before. Here we run a for loop, and we eval a certain variable that has been said before, how many threads this has to run. So basically just another subscript use, slightly complex. Then here, another example of how you can have a multi-line statement, just ending all the way at the end here with this redirection into this file, and just a number of replaces. So we're just getting a certain file, doing a number of replaces, inserting it into another file which is used later on. We then make it executable, sleep for a little while, and run it. Okay, so here we have another command that we haven't seen yet. I believe we looked into the kill command. So the -9 just basically means the most forcible way of killing a particular process that's running, and we just wait for this process to complete, for this kill to complete. In this case it's used as a little bit of a hack, but you can also use to wait for something to happen. So let's see if we can exemplify this. We're going to sleep for 200 seconds, and we're going to do so in the background, and we're going to check what our last started process is, which I suppose we could have just grabbed from here, and we could wait for this particular process. And now we should have just selected a shorter sleep. Let's just say sleep 10, be quick about it. So we're going to wait for 87, this one. So we just have to wait for a few seconds now, and this script is waiting. There you go, it's completed, and we return to our prompt. So it's a handy way of waiting for a particular process to complete. When we're in a for loop, we can use a break to exit out of the for loop, and that would be the most recent one. So if we had 5 or 6 for loops in a row, and in the 6th one we would have a break, we would only jump out of the most recent, or the 6th, whichever one, like the 6th loop, we would jump out and jump back into the 5th. If we break there, we would jump into the 4th, and so on. So break in this case would jump out of this for loop, even though there's a bunch of ifs and whatever, that doesn't matter. We break out of this for loop and we would end up basically here, right? So we're literally done with executing. The same happens with while. Let's suppose that this is a while statement. We have a number of things happening, and at some point you say, no, I don't want to stay in this loop, I've seen enough, break, and we come out. This might be handy if a certain condition has been met, for example. Let's maybe exemplify this in real life. So we can say while true to, so we remember this example from before, and I might just want to add a bit of a sleep here to make it less verbose. And we're just going to say if the directory test exists, then we're going to break. Okay, so it's looping. I'll just scroll this up a bit, which doesn't work. I'm just going to try and just put this on the side here. And now we're going to make this directory test13. Okay, so this directory was created. We just need to create it in Percona QA because that's where it's checking for the presence. And there we go, it comes out of that. So now the break was activated, so some condition was fulfilled and the while loop could be terminated. And there's the sleep that has just ended as well. Okay. Let's see what other interesting items we can find. I think we're looking, yep. Okay, so here again, just executing something which is variable based. That works just fine, there's no problem with that. Okay, so here we have elif, which we haven't seen either. So basically we have an if statement, then another if statement. Now, if this statement didn't evaluate to true, it will go into else. But here the else would straight away entail a new if, and sometimes it's easier to write this because just picture if it had here else and then if, else, if, else, if, and you would have a very deep hierarchy which would be very hard to read. Well, we can just write else if. So if this isn't true, well then check if this is true or if this is true. And this is in this case handy because we want to say, depending on some sort of level of variable, we want to just assign a different chunk size. And then finally at the end we can still have an else statement just in case all of these aren't true. Then we run this and we just have to do one closing fi which will close off this one, and this else is for this particular one up here. So very powerful syntax you can use in combination with if. Let's see if we find something else which is interesting. So in this case here we're using a multi-line statement which is encapsulated here by these double quotes, and this works fine. If we do something like this, we don't have to use those backslashes at the end because Bash will understand that we're starting a string here and we're ending it somewhere later. This can also work against you when you've put a single double quote somewhere, for instance up here where we're assigning some variable, and you forgot to put it at the end of the line, and all of a sudden all of your text is being seen as text, while it's not. There was simply a forgotten double quote. That also reminds me, if you have a particular script, let's say we're just going to do something really simple. So just some very straightforward commands, and we're going to make this executable. So we have 1, 2, directory output and the date. Now let's say you have to debug this, and let's take for instance that we've done something like this. Notice how if you use color coded VI, you will already see exactly what's the issue. But if you try and run this, it doesn't work at all, and you have to fix up your mistake. Now, if you're doing very complex script debugging, then it might get a bit more tricky than this. In those cases, you can use sh-x, and this will give a very detailed output of exactly what's happening. See, it says, okay, I'm doing echo 1 here, 1, echo 2, ls, date. Let's see if it would have helped in our example that we gave. Possibly not, but we'll see. Okay, so at least we saw what it got up to, and we more or less should have read exactly what it was saying. I'm looking for a matching double quote and I didn't find one. Notice if we add it here, it will still work, but our output is not as expected because we're echoing text here, but we're not executing the ls command, which makes sense because we put the quotes in the wrong spot. Okay, so all that is fairly straightforward and obvious. Here you see a use of the tail command, but a variable in this case. We're again grabbing something, so it's not that hard to read. Look, start of the line, end of the line, so we're looking for a full line here. We're minus v, so we're filtering something. We don't want something in there. So what is it we don't want in there? We don't want something in there that is tab or space any number of times, then an SQL terminating statement, and then after that you can still have a number of tabs or spaces. How could we slightly improve this? Just something I happen to notice. We can just say this. Very straightforward. If we see a line, a full line, we're checking for a full line, that has just tabs and spaces and potentially one or more terminating SQL statements, filter it out, because it's not really going to matter in SQL replay because the line in itself doesn't do anything. Okay, so here we check for a certain condition, if it equals 1, and depending on that we set some different variables. We run a command which is basically a variable, and this variable is got the full binary path and location in there for pquery. It runs that, uses a certain in file, and you can see all these variables being used in inside your syntax. So in here we're using egrab again. Remember that you have to use egrab and not grab if you want to use the or statement. And we're filtering a whole bunch of lines. For instance, any line that's a remark line, or any line that's empty. It starts and finishes. So you can see straight away we've filtered just by this little bit. We've filtered all the lines that are a remark, that start with a little sign like this, and then we have filtered all the lines that start at the start and then straight away finish. In other words, empty lines. Again, we could slightly improve this by checking for tabs and spaces at the same time. So we could say something like, well, if you see a space or a tab any number of times, besides seeing, because you don't really have to have this means 0 or more. Remember, this means 0 or more. If we do this, it means 1 or more, so we don't want to do that. We want to say 0 or more occurrences. Then just filter that line. Okay, let's see what else we can see. Okay, so here we have those ifs again, and depending on the trial number, it's going to do a certain amount of filtering. It's going to use just some regex syntax with together with set to do a number of replacements. For instance, going to try and replace the word table by t to make the SQL syntax less complex. Here in this case it's going to look for a closing bracket, any number of spaces or tabs, or at least one in this case, and then another comma, slash, bracket, and I just need to look here. Okay, so no, it's not looking for a slash. If it sees this particular text, so in other words a bracket, then at least one space or tab, but possibly more, then a comma, then it will just simply change it to a closing bracket and a comma. Just a tiny little cleanup there. Okay, just a whole bunch of replacements that are happening. So here you can see a break happening, so we know that it will break out of this while loop that is happening here, just another full while true loop. And you can see how based on all the previous parts we can really sort of reconstruct most of the things that are happening here. Here it grabs from a certain file the number of lines and it puts that into a variable. Here it does a calculation, so we haven't really seen calculations either, but it's very straightforward. Oops. So let's say that we say var1 is 1, and then we say var1 equals, and we want to use this syntax, so dollar bracket, var1 plus 1, just output, and that's 2, right? So we've taken the variable, we've added 1, and just notice this syntax. So there's a few tricky bits, like I wouldn't do this too much. There might be some parsing errors in certain places. In this case it probably just works fine, but if you get a bit more complex you might run into issues. Okay, so here we're excluding, using egrep, both lines that have insert, notice this or here, or something that starts and ends, so full line we're looking for, where there is a space, and then and we're escaping here and selecting here either a left bracket or a right bracket, and then just a blank space. Okay, so that's just some examples of existing scripts that you can go and look a little bit further. There's a whole bunch of scripts. You can also branch n for the reducer script. So the way to do that is bzr branch launchpad rangen, and then once you have it, just go into the rangen directory, util reducer.sh, and you got within Percona QA all the other scripts sitting here. Startup is an interesting one that we've looked at. Prepare, pquery, reducer is an interesting one, but there's a bunch of other scripts. So just have a look at the size. Usually the ones that are a bit larger would be the ones to have a look at. They might contain interesting information. So here's another example, and so on. Okay, enjoy reviewing some scripts and getting to learn more about Bash in general.